All right. Let me share my screen. All right. Okay. I'm pretty sure you can see. All right. All right. So for this problem, the basically we're gonna have a binary search tree. Right here is like the class structure for the tree node that you can use.
Okay.
And basically, what the function is called mirror. It's a void mirror function. So basically, what you want to do is given a like search tree, kind of like split it down the middle and like it's just inverted. So all your like left, um, all your nodes on the left will be the nodes on the right, and then vice versa. And your root node will stay the same since it's like in the middle.
All right.
Okay.
Are there any?
Constraints. It, it's just a binary search tree. There's no guarantee that it's full or perfect.
Cool.
So you can have like staggering.
Like root nodes with okay. Okay. So the way I would go about this problem is I would check. I want to recurse through the tree, so I'll have a base case where if the root is null, like return.
Yeah.
And I will go into each left and right child. Draw. And for each of those, I think I would like swap. I would like recurse first and then swap the left and right child. So let me see if I can work this out in code. This would be like a Boolean function, right? Or no. Void.
It could be a void, or you can also, well, we could make it void, but if you wanted to, you can make it to where it returns the root of the tree. But for whatever you feel more comfortable with.
Yeah, also bear with my like violent typing. My mic and camera are both situated in a really weird spot. I get a lot of action from my fingers. Yeah. Yep, made it to. I think what I want to do. So what I would do is like first swap this, creating a temp node.
If you want, before you like finish the code, like if you can give me like a rundown just on like a pseudocode, like how you would run through it, just like without like doing like actual C++ code, you can just like bullet points what you would do.
That can also. So I think with like the first, kind of the way I think their code is like working on like, I guess like trying to like code it in first. But okay, so we started the root and we want to swap the left and right subtrees. So that's what I do, swap these. But I want to make sure it's recursive. So either before this or after, I would want to recursively call the same method on root left and right. So, yeah. So I guess like my pseudocode would be like 1 base case 2 call recursively recursively and then swap left. Yeah. Okay, so swap these. I think I would want to. Well, I think I'm at the root. I would want to swap the 2 children already. And that seems so then. And the point of this is that recursively the swapping would like cascade down. Yeah, so let's, I guess
So
like,
you would swap them the child first and then recursively go. So you're basically inverting all the way down first. So you're doing like roots first and then children all the way down, correct?
yeah.
Okay.
Yeah, I think something I can do to like check it would probably be like thinking of like a specific tree. So on my paper, like I can't really do this on the doc, but let me like write this. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so start with a tree like this. Nice. And start at the root. If there's no point to return, that's good. So then let's see, 10th is left. Is left. Okay, left becomes right. So that becomes 2. Becomes 3. And then right becomes 10th. That's good. And then the children are the same. 6, 7, 4, 5. Okay, so after the block of code where they swap, based on my idea, I think it would look like this, swapping the 2 nodes. Because we have temp assigned to this one, it seems the node. And then we have recursion, so invert tree root left. seems good. Let me start at 3, small pointer return, and then swap the left right. Okay. I think that's good. I think this is what I would submit.
Looks good. Okay, so now, so let me just write some. Okay, so now what we're gonna do is we're gonna do kind of the same concept, but we're gonna have the data structure be in an array. So, and we're gonna assume it's gonna be like a binary search tree stored in an array with the constraints being that the parents of an index at I, whatever it would whatever index you're at, the children will be at 2i and 2i plus 1. And so it would be the same process to invert it.
You explain what I means?
Okay, so let's say you have I'm gonna make an array right here. So we have our root node. Let's say left of it is 3, 5. And could be, let's see. Okay. So we have right 17.
Oh, okay. I see.
So our root would be obviously the first one, and this is index 0. So your children would be at 1. Hold on, I think it's 2i plus 1 and 2i plus 2. So at index 0, your children will be 1 and 2. And then, so let me write out like the graphical representation. So let's say we have 10. Oh, it's going to be kind of hard not to. I have it drawn out right here. I don't know if you can see.
Yeah. Oh, okay, okay. Let me copy that down. Got it. Okay, so the bottom one is n minus 2. Or like the left child is wait. children at I. Is it based on the indices?
Yeah. So yeah. So yeah. So if we look at the first root, so I can at the bottom I'll put the indices. So this is index 1 or 0, 1, 2, 3, 4, 5, 6. So based on the graph, if we start at 10 being the root, it would have children of 7 and 15. If you plug in an equation to the I, would be 0. So then you just be indexes 1 and 2. And then if you start with child or your root node at 7, your children would be 5 and 9. So 2i, so 2 times 1 plus 1 would be 3, and then plus 2 would be 4. So your children would be 5 and 9, and so on.
How do we get 7 for this one child?
So yeah, 10, I just inserted 7 would be low, it's lower than 10. It's to the left, and then 10 to the right.
Okay, so we only start calculating when I is 1, I guess. Sorry, I think I'm struggling with this.
And for simplicity, you can assume that the tree would be perfect, so we don't have to worry about resizing.
Okay. What's the challenge for this? It's build a tree?
Yeah. Oh, well, just kind of in place. If you want, you can build a tree from the array, or you can also try to do it in place in the array.
Oh, okay.
Like manipulate it in place.
So I don't fully, I haven't fully grasped the index thing, but I know that I think I can just use in order traversal, put the array into the tree. If we have already, with pre-calculated values. Okay, so I'll make a quick solution. With special tree. And then, yeah. Okay, so my idea is just to go through the array and set new nodes for each value based on the order they're in. And I don't know if that's the same as the problem, but we go and Um, root the I think the pseudocode for this would just be, since we're building a tree out of an array, one would be to set the root, set the current root value to the first
one. Right, correct.
Like delete the first value from the array. Although that seems kind of sus. And then like pass in like the smaller version. And then like root left is special tree. Okay, we pass in like the left value. Left tree. And I'm actually gonna make a change where this would be like pre-ordered. I think I want order. So. Okie dokie. That's all I got. This is probably like way different from what you wanted, but there we go.
So my question is, what you said you wanted to delete values from the array as you're inputting the values from the array into the root.
Yeah.
So what I would suggest is that you don't do that, since the array is like since the tree that we're going to be manipulating in array form is perfect. There's like just the way the amount of how many nodes you have in total. Like it would be easier to not delete values from the array, if that makes sense.
Yeah.
Okay. So what we can do is we can just start. Let's say we just have an array of size 2. We'll make it easy. So just using this array, how would you do it? How would you flip it? You're right with the just adding the first index, the first value of the array is just the root. So that's good. So then you have your left and your right, and you want to swap
them. So we would do the like root first. Okay. And then so we set left to 7 and right to 15.
Yeah. So you will want it to be 10 with the root, 15 on the left, and then 7 on the right.
Oh, yeah. Mm.
And the reason why, like I said, it would be better not to delete, because if you delete values from the array, then this property kind of you mess with that. So.
Okay.
So it's better not to delete.
All right. So, Like I'm thinking like we would want to
Or
have.
you know what? I think deleting could you could also yeah. I think deleting could work. Never mind. My apologies. I think
I could like keep a counter for the indices, but I know this is probably a better way to do it. Yeah, honestly, I'm kind of stuck.
so. What? Uh, so we have the first part where we just add 10 to the root. So then what you would want to do is now that since you're at I, so you would want to iterate through first first and foremost, you want to iterate through every node at the um
Um,
in the array. So then what you can do is um for every element that you've iterated through, then um so it would be as you go down, the number of nodes per what is it called per level um, increases by a factor of two. So at the first level, you just have one, right? Since we're guaranteed that this is a perfect tree. So at the first level, will be one. So there you didn't have to uh, flip any children. At the second level, you have two children, so you would only have to do two swaps. At the third level, there would be four children from like we have four nodes, so you would have to flip four, and at the fifth would be five, and so on. So what you could do is have a for loop that iterates through every single node, and then another for loop that iterates through every node at that level to where you actually have to swap. So the first for loop is just getting the element that is considered the root of your subtree, and the second for loop is you swapping the the um, the children at each level, depending on how many how many children are at the level. So I'll write it down for you. Number. I don't know if it's so starting at level one, you would have two one minus zero, two to the one minus one, which would be just two, and then so on.
yeah. Um, yeah, I was thinking of. Okay, gotcha. Yeah, it made me think of the level sum like problem. I kind of had forgotten, but there was like a technique where we use the stack.
You could use a stack to help simplify things.
Yeah. How are we doing on time? Do you want me to like try and solve this?
Yeah, you could.
Okay. I'm gonna like go ahead and look at my level sum code just to refresh. Yeah. Okay, so for the iterates through every node. I'm gonna start with that. Let's change this. Um, there's stack of tree nodes. And then in order to get like the ones at each level, actually this is a cube because we want it to be first in, first out. In order to like order the nodes correctly. Okay. Q. Let's say we can push to Q. Push first. One new node. Pretty sure the Q like popping off is like top. Q dot like is node okay, so this loop, we want to go through each level And then we said like for like that level, we would have like that squared number of like swaps.
Two to the level.
Hmm?
Would, two to whatever level you have is how many swaps you would have to make.
Okay. So okay, for let's say like not how swamps. So for this part, I'm gonna make a new variable int level count, which starts at 0 and increments each time we go through this for this for okay. So for I to number of swaps, I think we could have could I just like call the invert tree function that I defined it? We'll do something like that. Hmm. So this is like super rough. But so the idea is use a queue to like order the different like nodes and for each level we perform like the number of swaps based on like the root popping off a node here. And honestly, I think this is broken. But I think if I like worked a little bit longer, I could like figure out how to like do this, like the inversions at each level. That's the part that I think I'm struggling most on. And then we also want to go like is there, I guess the idea is to do this recursively as well. Is the point of this function to like be able to call it as a helper function for?
So what would make it easier is you could just build the tree in place and in your So from the array, you just build the tree, and then you can call the function that you made before with the invert tree. So the tree would be built from just the array, and I guess you could swap it.
Okay. Tree. Okay, so the tree insertion. Honestly, I'm like I think I've been like confused with this prompt, but
So
well,
what we could start by doing is just do a for loop, because there is a way to do it without queues. This is just building the tree from the array. So what you would want to do is make a for loop that just iterates through every element. Correct.
you said every other element.
Yes, every element in the array.
And I guess like current left. Um, node. So something like this, where we add a new node to every other index based on a for loop, and from there, would we create another like for loop?
So in this case, since you want to hit every node, you would just, your increment is just by 1. And then within the for loop, you just inserting into your tree.
Okay.
So if you want, you could make a insert helper function just so you can like make it easier.
Yeah, that makes sense. Okay. Insert, like, that one makes sense to me. Behavioral tree project was something. Okay.
So if you want, you don't have to, since the premise of the question is just the building in place, we'll just assume that this is already built, like the insert. So we can just, you don't have to worry about it. Just put it in just assume that it's built and it's correct.
Okay.
So you don't have to write the definition for it.
Gotcha. Okay, so after that, based on, I mean, like you said, we could just call the invert tree function.
Correct.
And that would be the algorithm?
Yep.
Okay. Woo!
All right. So everything went well. You asked a good amount of questions just to get a grasp of the like understanding of what problem you were doing, and you the first problem you went through it pretty easily. The second one took a little more time, but you definitely just got through it. Any improvements? I would just say just explain more of your thought process, but in terms of writing the code down and methodically going through, everything was fine. And yeah, that's pretty much it.
Okay, nice. First interview done.
All right, yeah, first one done.
I guess, wait, do you want to keep recording?
So we can, I think we can pause it. Or we can just continue recording.
Okay. So feedback done. Let's do the next one. Yeah, you can stop the recording.
Stop it. Okay. So you want to start a new one?
Yeah.